The figure below shows a triangle OBQ in which OS is a third OP, OS is a third OP. So from here, if I divide by OP all through, here if I divide by OP, I divide by OP, so this OP and OP cancels. So that means that OS over OP equals to a third, meaning that OS into OP is 1:3. OS to OP is 1:3. So that means O to P is 3 and OS is 1. Therefore, this is 1:2. If we are talking about OS to SP, it's 1:2 because OP, the line is 3. And this one, if I divide by OQ also, if I divide by OQ, I divide by OQ, so OQ and OQ, so that means OR over OQ is 1/3. So the whole of OR is 1, O to R is 1, and O to Q is 3, meaning now 3 minus 1 is 2, so here is 2. So OR to RQ is 1:2. Then T is a point on QS. On QS we have decided that QT, it is 3/4 QS. So if I divide by QS, I divide by QS, so QS and QS will cancel. So meaning that QS is 4 and QT is 3. Q to T is 3 and the whole line is 4, meaning this is 1. So QT to TS is 3:1. Is 3:1. So if you interpret it that way, now you'll be able to solve the questions as asked. You'll be able to solve these questions as you are asked to work out. You'll be able to work out as you are asked. So from there you can work out. Given that OP is P, from O to P is P factor, the whole line is P factor, and I'm told that that is P factor, and I'm told that OQ is Q factor, O to Q is Q factor, this is Q factor, this is Q factor, and express the following factors in P and Q, in terms of P and Q. So SR, I want to express SR, S to R, S to R. So S to R, I can move SO plus OR. It is equals to SO vector plus SR vector. So SO is negative. Remember, we were given OP. So SO is negative 1/3 of P. It is negative a third P factor. P factor plus SR plus OR, and OR is now, because we were given OQ, we were given OQ as Q, so OR is just a third of OQ, which is Q. So it is a third plus a third Q factor. So this one can be equal to a third Q factor. Even if you leave it this way, it's correct. So it can be a third Q factor minus a third P factor minus a third P factor. So that is how you want to do it. Then QS, we want Q to S. We want to move from Q to S. From Q to S, you can come Q O plus OS, which is equal to QO plus O to S. Remember to write the factors. It's good to show their factors. So which is equal to QO. Q to O, you are going the reverse, so it is negative Q factor plus OS, negative Q factor plus OS plus OS, and OS is just, you're going to, the direction is a third of OP, which is P factor, plus a third P factor, which you can still write as a third P factor, minus Q factor. You can write it that way, a third P factor minus Q factor. So that is how you're supposed to write it. Then you're asked next that you can move down here and solve. Now, we are talking about part 2. The next part is that we find PT from P to T. Remember, our P is there to T. So from P to T, I can come PS, P to T, I can come from P to S, PT, PT I can say equals to PS, because you can move from P to S, PS factor, PS plus ST plus S to T plus ST. Now you'll find that this is equal to, from P to S, remember we are going against the direction. Remember this was 1, 2, so it is negative 2 of Q. So it is negative 2Q. Of P, because this was P, it's negative 2P, negative 2 over 3P factor plus ST, and ST, it is just negative a quarter, that is negative, because you are going against ST. Remember you were told Q2 to S. So ST is negative a quarter of QT, negative a quarter of QS, of QS. And the QS I know is QS, Q to S, I have already found it. So it is negative a quarter of QS. So where we have QS, we substitute. Is negative a quarter of QS, and the QS we have found it to be a third P minus Q. It's a third P minus Q. Now if you simplify that and you put the right terms together, this will be negative 1 over 12. and this will be positive a quarter q. So negative this minus this, that will give you negative 3 over 4 p, because the like terms you put them together, which gives you negative 3 over 4 p plus a quarter q. Negative 3 all over 4 p plus a quarter q, which you can write and say is a quarter q. So you can write it to be equal to a quarter q factor q minus 3/4 p factor. So that is the answer, and that is how you do it. And then we move to our next question on the same. Our next question on the same is that we find TR. We find TR. So our TR, we can equalize TR to be equal to, TR will be equal to TS plus SR equal to TS plus SR. TS plus SR, which is equal to, TS is negative, that is a quarter QS. TS is a quarter QS. It is a quarter QS. A quarter QS plus that is SR. We have found it. We found it from above. SR we found it to be a third Q. That is a third Q factor. A third Q factor. We found it to be a third Q factor minus a third P factor minus a third. That was our first. It was minus a third P factor. So from here, this will be equal to, if we now use the quarter QS, it is a quarter into QS. We know it's a quarter into QS, that we have already found QS to be a third P minus Q. This is a third P minus Q, then plus a third Q plus a third Q minus a third P. So that if you put the like terms together, here you open this bracket, it becomes 1 over 12. That becomes 1 over 12p. 1 over 12p minus a quarter q. We are opening the brackets here, minus a quarter q. Then we say we plus a third p plus a third p minus a third, this is plus a third q plus a third q minus a third p plus a third q. It's not p, it's a third q plus a third q minus a third p plus a third q minus a third p. so that if we put like terms together, this and this one, this one and this one, so we shall get negative a quarter p, negative a quarter p plus 1 over 12 plus 1 over 12 plus 1 over 12q. This can still be equal to, you can equalize and say it is equal to 1 over 12 q minus a quarter p. Good. Then you are asked that after doing all that, you hence or otherwise show that points P, T, and R are collinear. Remember now we have found either P, we have PT, we have found PT, and we have found TR. We have found PT and TR. So we can easily say that because we have TR and PT is from above, so we shall say that we can say that we let PT factor, the ones that we have here, PT factor, to be equal to K, to be equal to KTR, KTR. If we let it to be that, so that means PT, I know is PT, I have PT from above, and we found it to be 1 over 4, that is a quarter. We found it to be a quarter Q factor, a quarter Q factor minus 3/4 P minus 3/4 P. This is equal to K, equals to K into TR. TR we found it here to be 1 over 12Q into 1 out of 12Q. 1 out of 12Q minus a quarter P, minus a quarter P. So if you found it there, so that you have in the brackets, meaning if I equalize Q and Q, I can be able to get the one with Q and the one with Q. If you open, it will be 1 over 12KQ and a quarter Q. We equalize, we cancel Q, we are able to get K. So I can say that a quarter Q, and even if I use for P, it will give me the same value for K, equals to, a quarter Q equals to 1 over 12 KQ, meaning that I can cancel Q, so that I remain with K. For I to get K here, it is a quarter divided by 1 over 12, which is a quarter times the reciprocal. It is a quarter times 12 over 1 times 12 over 1. This gives you 4 ones, that is 3. This gives you 3. So that is the value of K. So if that is the value of K, we can easily say that PT factor, it implies that PT factor equals to 3 TR factor, 3 TR factor. And this is to show, and therefore we say because there is a common multiple, so that means PT is parallel to PT is parallel. The two lines means parallel is parallel to TR. Is parallel to TR. And now that they are parallel, since we say that since in this case T is common point, since T is common, then the 3 points P, T, R are collinear. collinear. They are collinear. So you show they are collinear if points are collinear, if they are parallel and if there is a common point. Like I've shown they are parallel by looking for a multiple, a common multiple. If you find a common multiple, then that means they are parallel. And if there is a common multiple and there is a common point t in this case, then that means PTR are collinear. So that is how we show colinearity. That is how we show colinearity. Now we move to our question number 22. To question number 22. We do question number 22. We move to our question number 22. We do our question number 22. We do our question number 22. Get question number 22. We move to question number 22. The diagram below shows speed time graph for a bus traveling between 2 points, 2 towns, and the bus starts from rest and accelerates uniformly for 50 seconds. It starts from rest and accelerates uniformly for 50 seconds. So that means from here at this point, this is 50. And then it then travels at a constant speed. At this point it was traveling at constant speed. It traveled at a constant speed for 150 seconds. So from here to here is 150 plus 50. So that means at this point is 200 seconds. Meaning this is 150 here. Then, and finally decelerates uniformly for 100 seconds. Now this is 100 seconds, so it comes to 300 here. So it took 300 to cover, seconds to cover the whole journey. So this is 100 here. This is the deceleration accelerating. Then we are asking that given that the distance between the two towns is 2700, we calculate the maximum speed. If we write the maximum speed here, if we write that speed to be v meters per second, if we write it to be v meters per second, maximum speed in kilometers per hour. First of all, we need to find it in meters per second. So what we do, we know that area under curve, if we are given speed in meters per second, and that is a velocity time graph, area under curve gives you the distance. Area under curve gives you distance. So therefore, the area under the curve, all of this thing is a trapezium. This is a trapezium. And the area of a trapezium, we know that now 2,700 meters, 2,700 would be equal to area, it is half AB, that is half times the height. Height in this case is V in meters per second, into brackets AB, that is half AB times H. So A from here to here is from here to here is 300 into 300 plus from here to here is 150. That is area of a trapezium. That is formula. So if that is the formula, I need to add this one. So this gives me 2,700 equals to 450 V, 450 V all over 2. So if I multiply by 2 and divide by 450, it gives me V. V is equals to 2,700 times 2 all over 450. use your calculator, you'll find your V to be, you'll find your V to be 12 meters per second. It is 12 meters per second. If your V is 12 meters per second, to change from meters per second to kilometers per hour, it is we times that 3600, because we know 1 hour has 3600 seconds, so it is 12. That is, if we needed it in kilometers per hour, it is now 12 times 3600 all over 1000. We divide by 1000 because we know that 1 kilometer is 1000 meters. So all over 1000, 3.6 times 12, it gives you 43.2 kilometers per hour. So this is what we are asked to find, the kilometers per hour. So you needed to do some good work here for you to score your 4 marks. So that is how you are supposed to do to get the maximum speed attained. That's what you are supposed to do to get the maximum speed attained. After getting the maximum speed attained, now we are asked that we move ahead and do part B. We do part B, whereby we should find the acceleration. Remember, the acceleration is this part. This is where it accelerated from 0 to it was moving at a velocity of from 0 to now 43, which is 12 from here to here. That is when it accelerated, and that is what we are supposed to find, the acceleration. So what we do for us to find the acceleration, let us move so that we get enough space to do the questions. Acceleration. Now I'm supposed to do the acceleration. Now the acceleration here, we know that acceleration is final velocity. That is, acceleration equals to final velocity minus initial velocity out of a time taken. So our final velocity, we have found it to be 12. Now that we have not been asked to find the acceleration in kilometers, so it is 12 minus meters per second minus initial velocity started from 0 all of the time it took. It was the first 50 seconds. The first 50 seconds, that is the acceleration. So it is 12 over 50, which is 12 over 50 over 50, and this gives you 6 over 25. 6 out of 25 meters per second square, or we can call it in decimal points. It will be 0.24 meters per second square. Meters per second square. Then distance the path traveled during the last 50 seconds. During the last 50 seconds, remember the velocity from this point, from the beginning to that is 12. So at 50, the last 50, it's halfway, because we had 100. That last triangle has 100. So if it has 100 seconds, it has covered it in 100 seconds. So in 50 seconds, we shall have a halfway, which is 6 meters per second. So we use area of that, the last part, and we use 50. So it is distance covered will be area, which is a half now, times a small triangle of that is 6 times 50 times 50 times 50. This is 3, so this gives you 150 meters. That is the last 50 gives you 150 meters. So that is what we asked. The time the bus takes to travel the first half of the journey. So when we talk about first half of the journey, distance for first half, distance in this case will be equal to, remember the whole distance is 2,700. So we divide by 2, it will give us the distance for the first half of the journey, which is 1350 meters. That is the first half of the journey. So that means if you look at the diagram, first half of the journey, let us look at it. If you look at this diagram, first half of the journey, we can have a figure like this, because we have the first half of the journey. We can have something like, if we say this is the first half of the journey, so this will be a trapezium. This will be a trapezium, whereby we shall have, if we let this one from here, the time from here to here to be t. I mean, we know that from here to here is 50. We already know from here to here is 50. So plus, if we let this one to be t and this t, so it will be 50 plus t plus t. Times the height now becomes the 12. Times the height comes to the 12, and we know the distance. So that is how we'll do it. That is how we will do it to find the distance in the first half of the journey. First half of the journey. Yes, first half of the journey. So that is how we will do it to get that distance covered in the first half of the journey. So this is the distance. So we are asking to find the time the bus takes to travel. So the time that it will take, like I've said, it will be now. So that means that 1350 equals to, now 1350 equals to what we call a half times 12, because that becomes the height, into brackets. Our a is 50 plus 2t, because t plus t, 50 plus 2t. So we shall have 6. So we shall have, this is 300 plus 12t. 300 plus 12t. So we shall have 1350 minus 300. 1350 minus 300 will remain with, so it implies that this is what? This will be 300 plus 12t, which is equal to 1350. You take 300 this other side. So we shall have, subtract 1200, it remains 300, remains that 1050. 1050 equals to 12t. So I need to divide by 12. Divide by 12. Now t becomes 87.5 seconds. 87.5 seconds. Then remember, I need now the whole time, meaning the total time taken now for that. Total is equal to this 87.5 plus 50, the first 50 seconds plus 50, which gives you 137.5. 137.5. So that is the time it took. Seconds. 137.5 seconds. So that is the time it took. Now we move to our next question. Question number 23. Question number 23. Complete the table. Now just use your calculator correctly and fill this. You know how to do it. Like just 2x cubed. 2x cubed, meaning that you cube -2, you cube it, you times 2. -2, you cube it, you times 2. -2, you cube it, you times 2, you get -16. So this becomes -16. And this becomes -1, you cube, you get still -1 times 2 is -2. Then 0 and all that. The next it is filled. Then here you have negative x, so negative of negative 2 is 2 positive. It's 1 positive. Then here we shall have -2 because it's negative x. So here we have, now you add -54 plus 45 plus 3 plus -6, you'll get to be -12. You also add this, you get it to be 0. You add this one, you get it to be -2. Then finally here you get 28. From there you draw the graph. From there you draw the graph. Remember your scale. The x-axis is from -4 to 2. So you think of that one, I would not have a problem. But in the y-axis we have up to -50. And for the positive we have up to 28. So if we have such, then you look at your graph so that you are able to know where you can, of course, -50 is bigger, so the y, the x line should lie at the top here, so that if I think of having it at this point, then if I use a scale of 10-10, so that you have 10, 20, 30, so that means at this point it can work. If I use it at this point now, that means it can work. If my x is at this point, assume I will have it here, then -10, -20, -30, -40, -50, so it will perfectly work at this. If I use that, then the x now, remember, to the positive is 1. I can use 1, 2, 3 and all that, -1 and all. So let me use a line here. I call it a y. You draw with a ruler a straight line. You use your ruler to draw a straight line. Use your ruler to draw a straight line for accuracy purposes. And then you also have a straight line, horizontal straight line. You have an horizontal straight line. This is your x-axis and this is your y-axis. So if I talk of 10 now, positive, 20, and then 30, -10, that is negative 10, negative 10, negative 20, negative 30, negative 40, then negative 50. So that I know that we start with negative 4 is for negative 50. If I talk of here negative 1 now, negative 2, negative 3 here, that is each 5, and negative 4. We talk about 1, 2, 3, 4, 5. So we have for negative, we start with negative 4, negative 50, negative 4, you move down to negative 50, you draw a star, a mark there, negative 3, negative 12, negative 3 will deal with the negative 12. So negative 3, negative 12, remember how many are these? 1, 2, 3, 4, 5. So if we are dealing 5, so each contains 2. So negative 12 will be at, this is negative 3, negative 12 will be this 10, 2 of them, 1, 2 will be at this point. Will be at this point. So that we also have negative 2, 0. At negative 2, we shall have at 0, y to be 0. And then we also negative 1x and negative 2y. Negative 1x, then negative 2. Negative 2 can be here direct. Then we also have 0, negative 6. At 0, it is negative 6. Negative 6 will be, this is 2, 4, 6 will be here. I wish I used a different color to make those markings. If I used a different color to make the markings now, negative 0, we have said 0 is at negative 6 here. And then we move on, 1 is 0, at 1 is 0. Then at 2 is 28. At 2 we now move to 28. This is 22, 24, 26, 28 will be here. Now this curve will move, make a turning here, move, make another turning, and move upwards. So it shall have 2 turning points. So you draw a smooth curve, and sure you draw a smooth curve, make a turning, make another turning, then sorry, it should be a smooth curve. It is a curve, so you make such a curve. Then from there, after drawing, you get your 4 marks. For having plotted 1 mark, plotting will carry 1 mark. Then we shall have a mark for the curve. If you have used a good scale, you shall have 1 mark. There is a good scale 1 mark, for a curve 1 mark, plotting 1 mark, and then you also get for the axis also 1 mark. So that is you score your 4 marks. Then next question is that the next question is that by drawing a suitable line. So what you do, such a question that by drawing a suitable line, you solve. By drawing a suitable line, you use your graph to solve 2x cubed. If you are asked to solve 2x cubed, remember we are using this graph, 2x cubed, plus 5x squared plus 5x squared plus 5x squared plus x minus 4 plus x minus 4 equals to 0. Remember your original equation. The original equation, we used the original equation which was 2x cubed. The original equation that we were given was 2x cubed. 2x cubed plus 5x squared plus 5x squared plus minus x minus 6 minus x minus 6. That is y equals to this, equals to y. Equals to y. Equals to y. Now you also you subtract this or add so that you eliminate all of this, you remain with a straight line. So write this equation that you have here, that is 2x, you can have it in as 2x cubed plus 5x squared, that the equation that you need to solve using the equation from the graph, that is plus x minus 4 equals to 0. So for me to get a straight line, if I subtract, this becomes 0 and this becomes 0, and therefore I need to subtract for me to get y minus 0, it becomes y equals to negative 6 minus 4 is like minus 6 plus 4, which is negative 2. So I already have negative 2. So if I have negative 2, then I need now negative x minus x minus x minus x. It is negative 2x, negative 2x. And now I make a straight line for this one. So to make a straight line here, I have x, I make a small tape xy. So that's small tape xy. And then xy, I can use the intercept at x-intercept or at y-intercept. X is 0. So when x is 0, you substitute here. If x is 0, y becomes negative 2. Y is negative 2. Then if at y is 0, if y is 0, y is 0, then x becomes negative 1. X becomes negative 1. Then for me to have a clear picture, I can add some other values, like I may decide to have 2 for x, and I may decide also to have like negative 2. Like negative 2. I can add some more values, like it gives me negative 6, and this gives me, if I substitute, and this gives me negative 2, give me 2. So I can now draw like 0, negative 2. So I start with the x is 0, then negative 2, that line will be here. No, 0, negative 2, let me use this color. 0, negative 2, 0, negative 2. I will have a point there. Then I also have 0, negative 2, negative 1, 0. Negative 1, 0, I can also have that point there. There is also 2, negative 6, I move 2, then it's negative 6, 2 is negative 6, the line will be around there. Then I also have like negative 2, 2, negative 2 is 2 here. So from there I can draw a straight line, use a ruler and draw a straight line and draw a straight line. You realize that the line cuts this curve at one point only. Read the point. This might not give me the exact value. This 1, Remember, this is 1, so each has 0.2, 0.4, 0.6 and all that. So it is almost giving the answer, because the answer is 0.7 plus or minus. So x now, when you have solved there, you found that x equals to 0.7, so it is plus or minus 0.1. It is 0.7. You can read there because this one, so each has 2, 0.2, 0.4. Remember that it gives me 0.6, so it is plus or minus. The answer is 0.7 plus or minus 0.1. So that is the answer. So that's what you're supposed to do. Then the next question is that we also use the graph. This is but C Roman 1, now C Roman 2, C Roman 2. We are still asked to use the graph, so that we use the graph and solve. We use the graph and solve 2x cubed plus 5x squared minus x plus 5x squared plus 5x squared minus x plus 2 minus x plus 2 equals to 0. So we are dealing with the original equation that we have, and our original equation is 2x cubed plus 5x squared plus 5x squared plus x plus x minus 4 it is 2x cubed is our original equation plus 5x squared minus x not plus minus x minus x, then minus 6 minus 6 equals to y. Then we write this equation so that we see whether we subtract or add. So we write that equation. If I write the equation, which is 2x cubed plus 5x squared minus x then plus 2 equals to 0. Now if I subtract, because this will be 0 and this will be 0, so if I subtract, I get y equals to negative 6 minus 2 is negative 8. I get negative 8. Negative x minus x is like minus x plus, it's like minus x plus x plus x, because minus becomes positive, and minus x plus x is the same as x minus x, which is equal to 0. So the line that I'm supposed to draw is the line y equals to, negative 8, where y is negative 8. So I go to y is negative 8, I draw a line there. Y is negative 8. Negative 8 will be here. So I draw a straight line here. Y is negative 8. And then I see where that line cuts this axis here. It cuts the axis here. So you read the value of x there. So that means the value of x at this point will be negative 2 point. If I move to 2.8, it will be 2.8. negative 2.8, because this 0.2, 0.4, 0.6, then 0.8, 0.8, that is where, so it is in negative 2.8, x equals to negative 2.8, negative 2.8. So you realize that is where it cuts the x. So that is how you solve the questions on a graph. Graphs core questions are very simple to solve and easier. They are simple and easier to solve. So that is how you do. Then you score your marks like simple as that. So we do the last question, that's question number 24. We do the last question, question number 24. We do the last question, question number 24. The last question number 24. We do the last question number 24. Question number 24. It's talking about turning points. Question number 24 talks about turning points. That has been the question. It has been the question since 2016. It has been question number 24 all through in paper 1. So you never know. It might also appear this year, the same number 24 or whichever number. But it is most likely to appear because what happens is that the term turning point is alternated with the term stationary points. So it is either the term stationary point that is used or the term turning point. So question number 24 is our last question, number 24. Question number 24 is our last question. That is the equation the equation of a curve is given by y equals to 6x squared minus 12x minus 18. So from there you are asked that you determine the equation of a tangent to the curve at the point where x equals to 2 in the form ax plus by equals to c. Remember the equation of the tangent at a point where x equals to 2. So first of all, what is that point? We need to find the point. We need to find the point. So first of all, we need to find the point. And the point, to get the point, we need to substitute x is 2. So the point will be what? We need to get the point, and the point will be the equation of a curve is given by that. So the point will be wherever we have x we put 2, so it will be y equals to 6 brackets 2 squared minus 12 times 2 minus 18. If you use your calculator properly, you will find that y is negative 18, and therefore the point is 2, negative 18. At that point, we need to find the equation of the tangent at that point. So we need to know the gradient at that point. Remember, gradient at that point equals to the gradient of the curve. Gradient at the point where x is 2 is equals to the gradient of the curve. So gradient, that is dy over dx, which is gradient, dy over dx will be equal to, we differentiate this equation, it is 2 times that gives you 12. 12, the power reduces by 1, so 12x Then here the power is 1. Now 1 times 12 is 12, that is minus 12. And the power reduces by 1, 1 minus 1 is 0. So anything raised to power 0 is 1. So it means 12. So this is the gradient. And at the point x is 2, so that means the gradient dy all over dx, we substitute x with the 2 and get 24 minus 12, which is equal to 12. That is the gradient at this point. So if we know the gradient at this point, remember the gradient of that curve at the point equals to the gradient of the tangent. They are parallel. So equals to the gradient of the tangent. And therefore, we are asking the equation of the tangent. So that means we can easily find the equation of the tangent because we know the gradient is 12 over 1 equals to we let another point x, y to be on the line, on the tangent line. So that means equals to y minus 18 is plus 18 all over x minus 2. So we cross multiply, it gives y plus 18 equals to 12x minus 24. So here 12x minus 24. Now we shall have like terms together. So y, do we have the form? Yes. First of all, you can even rearrange in the form first of all, so that we have ax. So ax is what? Remember, it is in the form that you are told. If it is not, you don't get it correct. So ax, we bring, if I bring 24 here, it will be added, and 24 plus 18 gives you 42. So we shall have 12x, then minus y. It will be 12x minus y. It will be 12x minus y equals to 42. 12x minus y equals to 42. 12x minus y equals to 42. So we shall have 12, because this 12x, then we take y, the other side is minus y equals to 42. 12x minus y equals to 42. That is in the form that we have been asked to write. This is the form and this is the answer. So that is how we calculate the equation of the tangent. The equation of the tangent equals to the equation of a curve at a given point, because they are parallel. Now, we talk about the turning point, how to find the turning point. We've calculated the turning point and classify that turning point. That means classifying is saying whether it is a maximum or a minimum. Classifying is saying whether it's a maximum or a minimum. So what you do in that case, that you classify the turning point and say whether it's a maximum or a minimum. The turning point, we know that at turning point dy over dx equals to 0. At turning point dy over dx equals to 0. So we know that dy all over dx will be equal to 0. So that means that dy over dx is our dy over dx, we found it to be 12. It implies that 12x minus 12 equals to 0. 12x minus 12 equals to 0. So from there, meaning that 12x equals to 12. 12x equals to 12. So that means that x is equals to divided by 12. So x equals to 1. So if you have x equals to 1, when x is equals to 1, we find what y is. When x equals to 1, so that means we use the original equation to find what y is. Equals to 1 then this one, then y equals 2. You substitute in the original equation, that is 6 1 squared minus 12 times 1 minus 12 times 1 minus 18 minus 18. So y becomes, which is equal to negative 24. So the turning point is 1, negative 24. So that is the turning point. So the first thing was to find the turning point. Then from there, you classify that turning point. Remember, we said that to classify whether it's maximum, minimum, or a point of inflection, we can use the second differential. But if you differentiate this the second time, you get just a whole number 12. Remember, a whole number 12, you cannot be able to substitute the dy over dx. So you'll have a challenge in doing that. So we better use the first differential method. First differential method, whereby we draw a table. Remember, dy over dx, we have found that x is 1. So now that we have found that x is 1 here, so we shall have a table with value of x, and then we also have dy all over dx. In this case, we have only 1 point proving. Then we have the nature here. So we have the nature. So if this is your table, x, remember, we have value of x is 1. Then to the left, we can talk about 0. And then to the right, we can talk about 2. Then when it is 0, if x is 0, dy over dx will be what? If x is 0, dy over dx will be negative 12. Dy over dx will be negative 12 because this is dy over dx. So it will be negative 12, so this is negative. If it is 1, then 1 times 12 is 12, 12 minus 12 is 0. So when it's 1, it is 0. And when it is 2, it is 24 minus 12, which is positive 12. So it is positive. So if it is positive, then that means we can define the nature. The nature, negative, we said a line should be moving that way. Then at 0, it is moving this way. Then positive moves that way. So meaning this one is a minimum point. Minimum point. So being a minimum point, meaning that point 1, therefore point 1, negative 24, 1, negative 24 is a minimum point. Is a minimum. Is a minimum. It's a minimum point. This is a minimum point. So that's how you show the nature. That's how you show the nature. That's how you show the nature. So the nature of the points is a minimum point. Then the next question is that we have understood it's a minimum point. Next is the next question is that we now the next question we need to to find the x and y intercept. We know that at x-intercept, at x-intercept, y equals to 0. So that means if I substitute at x-intercept, if I substitute in my original equation y with 0, it will be 6x, it will be 6x squared, 6x squared minus 12x then minus 18 equals to 0. This is a quadratic equation. I can use formula method. X will be equal to negative p, that's minus b. So minus 12 becomes 12 positive, plus or minus square root, plus or minus square root of b squared is 144, minus 4ac, minus 4 times a is 6, then times, remember it's minus, then times negative 18, it will be minus, so this must be positive because of this negative. So plus 4 times 6, which is 24 times 18, gives you 432, plus 432 gives you 432, then all over 2a, 2 times 6, which is 12. So meaning that x, it is 12 equals to 12 plus or minus, that is the square root of 432 plus 144, you get, that is 565, that is the square root is 24, square root of that is 24, because 144, if you add 144 plus the 432, you get, this is 6, 7, 576. Square root of 576 is 24. So 24 all over 12. So meaning, if I had, gives that 6 over 12, x is equals to 3, x equals to 3, or x equals to negative 12, which is negative 1. So meaning that we can have the points. So the x-intercept is meaning the value of y is 0, so the point are what? So we have 2 points here, 2 points. That is x3, 0.30, and another point, negative 1, 0. That is where it cuts, the curve will cut the x-axis. It will cut the x-axis at 2 points, and the y-intercept, at y-intercept x is 0. So y-intercept x is 0. So y-intercept, we know that x is 0. So in the equation, if I substitute x with 0, then we shall remain with the negative, y equals to negative 18. So y will be equal to negative 18, meaning it will be 0.0, negative 18. That is the point. That is the point. So from there, you sketch the graph. Remember, you are sketching. does not mean it must, but it must be accurate because you must show the turning points and the points of intersections. So what you do, if that is your, okay, let me have a good sketch. Let me utilize the space well. Assume we have here, I have y-axis there. Remember, I'm talking about points. We have point -1. We have point x3. So I can have 1 somewhere here and 2 here. And then remember the y I have up to -18, and I also had another point, that is the turning point was at turning point was remember the turning point, you need to know the turning point was we found it to be 1 -24. We found it to be 1 -24. 1 -24. So that means I need to know all these points. These points, need to know this, I need to know this and this one, because I use them. So I start with I know at the longest here it will be -24. That is my y. I know there is a -18 somewhere, -18. Then I know there is a 1. Good, now I have all the points. If I have all the points, I can start with 1, I mean 1 and -24, 1 and -24. You can have a sketch there. Then I also have a point like 0, -18, 0, -18, there is a point here. I also have a point like 30, a point here. Also -1, -1 and 0, I also have a point here. So it means that there is a curve that is turning at this point. The curve is turning at this point, and there is that curve. There is this curve, that turns at this point. Good. So that is how you sketch the curve, because you sketch showing the turning point and the intercepts, the y-intercept, the x-intercept, and the y-intercept. It intercepts y here and turns at that point. So that is, you have sketched the curve. So that is how you sketch the curve, and then you score your 2 marks there for sketching the curve. So that is all you needed to do in this paper. Take it serious and revise on the topics that I've covered in this question. I shall have a paper 2 predictor question, and ensure to subscribe into my channel so that you'll be able to get all questions that I post. All questions that I post, you are able to get them and follow keenly. These are good questions. You can revise more on the same topics that I've predicted, so that you be at a better